Hi guys, welcome back. We are studying section 11.6 combustion reactions, and I'm working here with fifth period. They're my usual class that helps me because they are one of my best classes. So they'll be helping me with today's presentation from your CK12 packet. How do you cook the perfect marshmallow? So I don't know if you've ever gone camping or if you've ever just made like s'mores in the back of your house. The first thing that you need is that nice toasted marshmallow, right? You don't want to burn marshmallow because that's going to ruin the s'more. All right. But the question is, or how do you cook the perfect marshmallow? Who's going to help me?
Roasting marshmallows over an open fire is a favorite pastime for campers, outdoor cookouts, and just gathering around. The fire in the dark pot, the trick is to get the marshmallow a nice golden brown without catching it on fire. Too often we are not successful and we see the marshmallow burning on the stick and combustion reaction taking place right in front of us.
Wow. So did you ever know that every time that marshmallow caught on fire, you were doing a combustion reaction? Did you? Did you? I bet you didn't. Well, yes, it's a combustion reaction, right? Most of the time, you need two things in order for a combustion reaction uh, to classify it a combustion reaction. First, you need oxygen as a reactant. Well, oxygen floats around us every single minute of every single day, so oxygen is always available. The second thing that you need is, well, do you see energy in the form of heat and light? Well, if it's on fire, you can definitely feel that heat and you can definitely see the light. So, definitely is considered a combustion reaction. And that is the topic for today. Oops. A combustion reaction. And here you have a nice picture of another combustion reaction that killed some people. All right. But before we talk about the picture, let's talk a little bit about the definition of a combustion reaction. So, a combustion reaction is a type of reaction in which a substance reacts with oxygen gas and releases energy in the form of heat or light. Combustion reactions must involve O2 as one reactant. So, oxygen has to be present. If not, then it's not a combustion reaction. If you have O2 as your reactant, as one reactant, it's possible to be considered a combustion reaction. All right. And here you have your first example, the combustion of hydrogen gas. Anytime you have hydrogen gas undergoing a combustion reaction, it's going to produce water vapor. And you can see the formula in the reaction here. H2, hydrogen, plus oxygen gives us that water molecule that we love, right? And that we need. Okay. Notice that this is not only a combustion reaction, but you can actually classify it as a combination reaction as well, right? You have hydrogen and oxygen combining to form that water molecule. Many combustion reactions occur with hydrocarbons. Okay. A hydrocarbon is a compound made up of solely carbon and hydrogen, just like the name implies. Hydrocarbon, hydrogen, and carbon are in there? Definitely. The products of a combustion reaction when you have hydrogen or a hydrocarbon is always carbon dioxide and water. So it's really easy to identify. Okay? Why? Well, because it's going to look like just like you see down here. And something that's not going to change is the second half that you see here. The only thing that changes in combustion reactions is your hydrocarbon. Everything else is there. Oxygen will always be there, carbon dioxide will always be there, and water. Oxygen will be a reactant, carbon dioxide will always be your products. Okay? So they're really easy to spot. Okay? At least that's what my students have told me in the past. They're like, oh, miss, I can find a combustion reaction like this. And I'm like, why? Well, because they all have the same three compounds at the end: O2, carbon dioxide, and water. And I was like, oh, yeah, very true. So let's talk about the picture. In the picture, you have something known as the Hindenburg. The Hindenburg was, I think, a German creation, or I'm not really sure, but I think it came from Germany or from over there, somewhere over there. But either way, it was a hydrogen-filled airship that suffered an accident when it was trying to land in New Jersey in the 1930s. Oh, excuse me. Let me drink some water. Okay, so this ship, this aircraft, was traveling around and it got to Jersey and it was trying to land. And when it was trying to land, it combusted. The hydrogen inside the vessel, the balloon or whatever you want to call it, it combusted. It exploded. And it doesn't really tell us why or how, but I'm pretty sure there was some type of electrical source, either from the air, right, like thunder, like lightning, or maybe there was some power lines that were giving off enough heat so that it could ignite the hydrogen inside the aircraft. But what happened was that the hydrogen immediately combusted in a huge fireball, destroying the airship and killing 36 people. The chemical reaction was a simple one: hydrogen combining with oxygen to produce water. So it was the first reaction that you see here. Okay, this was the combustion reaction that basically destroyed the Hindenburg. I don't think there was many other people who wanted to travel using these aircrafts. Uh, so it was basically, nobody else wanted to use it after that, and it just went away. Okay. But let's continue. So remember, you have your first part of the question, and it's asking you, what is one reactant that combustion reactions must involve? So what's the one reactant that must always be present in order for a combustion reaction to happen? Anybody remember? And it's all around us. It's in the room that I'm sitting in. It's in the room that you're sitting in. What is in the room right now, in all of our rooms, that's part of this type of reaction? And I got one person writing. Thank you. Question number 2. What are the products of a combustion when you have a combustion reaction when there's a hydrocarbon? Okay, let's check it out. Oxygen. Very, very good. Oxygen needs to be present in order for a combustion reaction to occur. Very good. Very good. Okay, now number 2. Let's see who's going to get this one. What are the products of a combustion reaction when you have a hydrocarbon? What is always produced? What are my 2 products? Other than heat and light, what are my products? All right, so this is good. This answers number 1. What about number 2? What is always produced when you have a hydrocarbon burning up? What is always produced? Oh, somebody's starting to write. Let me give them some time so they can think. What are the products of a combustion reaction when you're burning up hydrocarbons? Like ethane, methane, butane, octane, pentane. All of those are hydrocarbons. All they have are carbons and hydrogens. What always forms when you react those guys with oxygen? What always forms? Let me see. Yes, carbon dioxide. And what else? There's one more compound. There's one more compound. What's the other compound? What's in here? What's in here? Yes. Carbon dioxide and water, guys. Carbon dioxide and water. And you got to remember, very good. Hydrocarbons are like, if you've ever gone to the gas station and you see octane, you're putting in hydrocarbon into your car. It's called gas, but it's got another name. It's called octane. Octane is another hydrocarbon. Every time you turn on that key, you turn the key and your engine starts, octane is burning to create the enough energy to power the motor and to drive you wherever you need to go. Okay? And what's produced? Water and carbon dioxide. Water and carbon dioxide. Very good, guys. Great job. Great job. Love it. All right, we got a practice problem, so we're going to go into Jamboard. So I have here the problem, and it says ethanol. Ethanol can be used as a fuel source in an alcohol lamp. The formula for ethanol is C2H5OH. Again, it's very similar to hydrocarbons, right? Write the balancing equation for the combustion of ethanol. Okay, so if you have ethanol and it's combusting, you need to write the equation, okay? And then they give you the formula. So we know the first half of the reaction just by them giving me ethanol's formula. We know that ethanol, right? C2H5OH plus, again, what is in the air all around us? What's in the air all around us? Oxygen. And any time, very good, Miss Dia. Anytime we have a combustion reaction, we always get the same products. Carbon dioxide and H2O, water. Okay? That's the skeleton equation. That's the equation, but it's not balanced. But we've been practicing balancing for already 1 week now. So we should be able to balance this reaction. How many do I have of each? How many do I have of each when it comes to carbon, oxygen, and hydrogen? How many on the reactant side and how many on the product side? Give me the numbers, guys. How many carbons? How many oxygens? How many hydrogens on the left side first? Let's do the left side and then we'll do the right side. Can somebody give me the numbers? Carbons, hydrogens, and oxygens. Give me the numbers. And I want all 3 of them, not just one.
2 in carbon.
2 for carbon.
5 in hydrogen.
5 or 6? Cuidado, muchacha. ¿Y este? ¿Se te faltó?
6.
6.
Oxygen 1.
Oxygen 1. 1 here plus.
3.
So 1 plus 2. We got to keep them separated, Miss Catherine. 1 plus 2 for a total of 3. But because they're separated by a plus sign, we also have to keep them separated. Okay? But yes, you are right. 3 is correct. What about on the product side, on the right side? How many over here? Carbons, hydrogens, and oxygens. How many on the right side?
Carbon 1.
Hydrogen?
2.
Oxygen?
2 plus 1.
Yes, very good. Okay. Where are you going to start balancing? Are you going to start balancing with carbon or are you going to start balancing with hydrogen? Never start with oxygen. If you see a plus sign in between the numbers, do not start with this guy. Leave him to the very end. Okay? So where do we want to start? Carbon, or do you want to start with hydrogen? Carbon or hydrogen? Carbon or hydrogen? Where shall we balance, guys? Okay, what do I do? What do I do, Miss Diamond? What do I do? I know I need a balanced carbon because I got 2 here and 1 here. How can I make this 1 into a 2? I need to multiply by something so that it equals 2. 1 times 2, very good. If I multiply this guy by 2, I'll make the 2 that I need, right? So that this guy can match this guy. So where does the 2 need to go? In front of carbon or in front of hydrogen? Where are we going to put that 2? I can put it here or I can put it here. Where does it belong? In front of CO2 or in front of H2O? Where does it go? Where does it belong? There's 2 places I can put it. Since I'm changed in front of CO2. Very good. Okay. Why? Because where's carbon? I changed carbon. Carbon is part of the first compound. Very good. Okay, what's next? I have a 6 here. How can I make this 2 into a 6? I know I need to multiply, but what do I multiply by? 2 times 3. I agree. Does everybody else agree with her? Oscar, do you agree? Jeremiah, Jose, Caitlin? Yeah, right? The number that's going to go in this blank to make a 6 is a 3. Okay, but, and there's a but. So my carbons and my hydrogens are balanced, but when I put those 2 and that 3, who else got affected here? Who else got affected here other than carbon and other than hydrogen? Who else got multiplied by 2? Who else? Oxygen, right? And it's the oxygen that had a 2. That's this guy right here. He's gone, right? He's gone. Why is he gone? Because 2 got multiplied by 2, right? 2 multiplied by 2 is, now I'm going to change it. I'm going to take it off and I'm going to put a 4. Everybody see why? Okay. Who else got affected here when I put the 3? Who else got multiplied by 3? Is oxygen still a 1? Or did oxygen multiply by 3? It used to be a 1, right? Don't I have a 1 here? But the 1 got multiplied by 3 because of this guy. So 1 times 3. 1 times 3. Right, it got affected. So this is not there anymore, right? It's no longer a 1. I'm going to erase it, and I'm going to put a 3 for a total of 7. So I need to make a 7 here. But I don't want to change the 1. And I'm going to tell you why. Why don't I want to change this 1? Because this 1 is here. So if I multiply the 1 times any number, it's going to change everything else that's connected to this oxygen. So I don't want to touch it because I already have my carbons and my hydrogens balanced. So I don't want to change that. I only want, so what I'm going to do is I'm going to say, okay, What's 7 minus 1? What does that leave me with? If I subtract the 1, how many more are left to balance? If I subtract the 1 from 7, what's left? I don't want to mess with this 1. So I'm going to say, what's 7 minus 1? Can I make this number into a 6, Miss Diamond? Can I make Catherine, not Catherine, Caitlin, Alexia, can I easily make this number into a 6 so that I can have 6 plus 1 and make 7? Can I do that? Can I make this 2 into a 6 by multiplication? What do I need to multiply here in order to make a 6? What goes in the blank? 2 times 3, right? If I multiply this guy by 3, I can get the 6 plus the 1 and make that 7 that I need, right? So what am I going to do? I'm going to put the 3 here, right? That'll make a 6 plus the 1 that's here makes 7. Everybody see that? Okay. Now I have 7. Oops, my bad. Now I have a 7 and everything is balanced. This is my answer. And you can look on the pair deck. Look, there's the answer. 1, 3, 2, 3. 1, 3, 2, 3. It's exactly like we did it. And you can count all the elements and you can verify that that's true. Okay? 2 carbons, 2 carbons. Let me see. 5, 6 hydrogens, 6 hydrogens. 1 plus 6 is going to give me the 7 that I have on the other side. All right. Now it's your turn. Those of you on pair deck, methane reacts with oxygen to yield carbon dioxide and water. Write down the equation for the combustion reaction. So I need somebody here on pair deck to write the reaction that they're talking about here. And they're to give you the formula, so they made your life easy. All you need to do is put them in the correct place. So use the space below and write this reaction where methane reacts with oxygen to yield carbon dioxide and water. Come on, guys. What do you think? Is somebody writing? All right. I got one person already doing it. Great job. What about the rest of you? Oscar, Mario, Alexia. All righty. Let's see. Who wrote the reaction? Very good. CH4 plus O2 gives us CO2 and water. Great job. Perfect. That looks really good, guys. H2O, CO2, and water. Okay. You think you can balance? Can you try and balance whoever this is? Can you try and balance this reaction? Carbon, hydrogen, oxygen. And it's a real easy one. It's super easy. Try it out. Good. Good. 1 carbon, 4 hydrogens, 2 oxygens. Good job. What about on the product side? 1 carbon, hydrogen. How many do you got? And oxygen. Keep them separated. 2 plus 1. Very good. 2 plus 1. Great job. Great job. Okay. How would you start balancing this? What would you start with? You don't want to mess with carbon. Carbon is good to go. I personally would start with hydrogen. Personally, I would start with hydrogen. I can easily make this 2 into a 4 by multiplying by 2. Excellent. So where does the hydrogen go? Where's hydrogen? In the first compound or the second? Where are you going to put this 2 that you have? Where's the 2 going to go? Is it going to go in front of carbon? Oh, very good. Okay, when you put that 2 in there, who else got affected? Who else got affected? Is this still a 1? Or is it 1 times 2? Very good. So this was a 1. So you want to cross this out or erase it and put the new number, right? 2 times 1, which is 2, right? 2 times 1 is 2. I would put a 2 here. Equals how many? How many does that equal? Can you make this into a 4? So now my carbons are balanced. My hydrogens are 4 and 4, but now my oxygens, I have 4 on this side, on the right. I have a 2 on the left. So look, very good. She or he says that we need to multiply by 2 so we can get 4. So what goes here? Where does the number go? Where's the number that's going to balance this part? Remember, you mess with oxygen. Where's the oxygen? In the first compound or the second? Where does the 2 need to go? This 2. Very good. And that's your reaction, guys. That is your reaction. You got 1, 4, 4, 1, 4, 4. And you're done. This is your correct answer. I don't know who you are, but you are doing great. Who's this? Write your name somewhere or your initials. Who's this? I want to know who this is so I can give them some extra points for doing that work for us. And I can actually give both people extra points. Diamond. Thank you, Miss Diamond. Great job. Great job. Perfect. All right. Who is the other one? Who is down here? Alexia. Thanks, Alexia. Both of you guys got extra credit. Great job. All right, let's watch this video. And he doesn't talk very loud, guys. And I already, the volume is already maxed out on my computer and on YouTube. So try it, try and listen. Chemistry tutorial, and in this tutorial, I'm going to be talking about combustion reactions. Now, this is typically a reaction you get whenever you think of fuels and gases. Basically, the key thing to remember is whenever you have a combustion reaction, one of the things it produces is heat. Now, the formal definition, I guess you could say, is a compound that combines with oxygen. And now, this oxygen is typically just oxygen in the atmosphere. And
balance this equation, you can see we have 4 hydrogens on this side, 2 oxygens, so we're good to go. So again, if we take a look at the ingredients needed to produce a combustion reaction, we have oxygen that our compound can combine with, and also heat. That's probably the most important thing you can take away from this story. Every time we have a combustion reaction, it produces heat, which would make it an exothermic chemical reaction. Now remember, the alternative to that is endothermic, which means the chemical reaction that absorbs heat or absorbs energy. But these chemical reactions are exothermic. So let's go ahead and take a look at one more example, and we'll go ahead and balance this equation properly. So I'm going to go ahead and take a look at, I think I'm saying this right, naphthalene. I don't know how to say it, but it's the compound they find. They use it whenever they make mothballs and that. That's just a nice little tidbit of information. You guys don't need to remember that at all. But anyways, the chemical formula for this is C10H8, and we're going to go ahead and combine this with, well, that's a really awkward plus sign. Combine this with like some oxygen, 12 molecules that balance nicely. Now, whenever we combine these, we get 10 molecules of CO2, and also we get some water molecules, H2O, and heat. And try my nice little E symbol. By the way, that is not the technical E symbol. You can just write heat, or you can leave it out. Some people leave it out whenever they're writing chemical reactions, but I like to try that nice little E. So anyways, let's go ahead and take a look and make sure we have everything needed.
All right, I'm going to skip ahead. All right, so let's talk about the balancing of this equation. And you can see that the numbers are got really, really big, really, really fast. That's what happens with combustion reactions. You're trying to balance, and all of a sudden your numbers are going to get really, really big. But don't worry, I have a neat trick that will help us get to these numbers. But either way, let's just verify the balancing because we're running out of time. So carbon, you can see easily that you have 10 carbons just by looking at the reaction, right? The subscript. Over here, we have 1 carbon in carbon dioxide, but it gets multiplied by 10. So there's the 10. For hydrogen, we got 8 because the subscript shows there's 8. And if we look over here, 4 times 2 is the 8 that we need. Oxygen, 12 times 2, 24. That's a lot of oxygens. Let's see if we can count them all. So oxygen's right here on carbon dioxide. We got 2, but 2 gets multiplied by 10. That's 20, right? But that's not the 24 that we need. So let's look at water. Water has 1 oxygen in the compound, but that 1 oxygen got multiplied by 4. So there's the other 4 for the 24 here. So there's some more examples, and don't worry about combustion reactions. I always try and pick the easy ones. If not, I always tell you my little secret on how to solve for it. But it's going to come later, okay? Right now we're running out of time, and I want to make sure we have practice time. So combustion reactions is defined and examples are given. Your review questions: what is needed for a combustion reaction to take place? 2, what is formed in any combustion reaction? 3, if mercury reacts with oxygen to form mercuric oxide, is this a combustion reaction? And then question number 4, what are the products of any combustion reaction when you have a hydrocarbon?